So in probability 29, we're going to do kind of a little scenario where we have a kind of a special deck of cards. It's got 4 aces and 3 kings. So there's a total of 7 cards in the deck. And the idea is if we draw 3 cards out one at a time without replacement, we're going to look at the different probabilities that we can have in this situation. So if you think about drawing 3 cards, that means we're going to make 3 draws. So I'm going to actually go ahead and make a tree diagram of those 3 draws. So on the first draw, you could either draw an ace or a king. And if you think about that scenario, if there's 7 cards in the deck and 4 of them are aces, then 4 of the 7 are the aces. That's the probability of drawing an ace. 3 sevens is the probability of drawing the kings. And that's on the first draw. So if we draw that, and then we're going to do this a second time, ace, king, but we didn't put the card back in, so this is non-replacement probability. So if we don't put the ace back in, then there are no longer 7 cards, and we're also down an ace, so there's 6 cards, and only 3 of them are aces. And out of those 6 cards, there's still 3 of them that are kings, because we didn't take a king in this case. And so that's the second draw on that branch. Now we're going to actually go to the second draw on this branch. Ace, king. And if we had drawn a king first, again, there's only 6 cards in the deck now. And there's a king that's gone, so now there's only 2 kings left. All the aces are still there, so now we have 4 out of the 6 remaining cards that are aces. And so that's the second draw on that branch. Now, third draw. So we're going to draw the third card and go up here to the top. And it again could be an ace or a king. But now on the third draw, there's only 5 cards in the deck. And if we drew 2 aces out already, there's only 2 aces left. If we drew 2 aces out, there's all the kings are left, 3 out of 5. So again, each time we're thinking of what happens or what could happen. In this case, if we drew a king, we still can draw an ace or a king. And if we drew an ace then a king, again, there's only 5 cards left in the deck. One of the aces is gone, so there's only 3 aces left. One of the kings gone, so there's only 2 kings left out of the 5 cards. And again, down at this branch, you can draw an ace or a king. And if we draw a king, then an ace, and again, there's only 5 cards left now out of the 7. An ace is gone, so there's only 3 aces left. A king is gone, so now there's only 2 kings left out of the 5 cards. And then the next branch, the final bottom branch, again, could draw an ace or a king. 2 cards are gone, 2 of them are kings. All the aces are still left, so 4 of the 5 cards are aces, and only 1 of the 5 cards left is a king. And so again, if we look at all of the different possible outcomes, we could have ace, 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 king, ace, king, ace, ace, king, 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 ace, ace. I'm just following these chains. King, ace, king, 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 ace, and finally king, king, king. And if we want to find the probability of any one of these scenarios, we just multiply across the fractions. So in this case, the top one is 4 sevenths times 3 sixths times 2 fifths. And so we're going to have 4 times 3 is 12 times 2 is 24. And then we're going to have that out of 210. And then the next one, we're going to follow this chain. 4 sevenths times 3 sixths times 3 fifths. So now we have 4 times 3 is 12 times 3 is 36 out of 210. Then the next chain, again, I'm just taking all these fractions and multiplying them together right across the chain, right across the tree. 4/7 times 3/6. I'm not going to worry about reducing the fractions at the moment. I'm just going to get all these calculated out. Times 3/5. And again, we have 4 times 3 is 12, times 3 is 36 out of 310. And then for ace, king, king, 4/7 times 3/6 times 2/5. So that's 24 out of 210. And I'm just going to keep going. This is replacement probability. It takes a lot of work keeping track of all of these fractions. So king, ace, ace is 3/7 times 4/6 times 3/5 right across here. So now I have 36 out of 210. At least I know this bottom part, because I didn't reduce any of the fractions, are all going to be out of 210. And then king, ace, king, 3/7 times 4/6 times 2/5. So again, I have 24 out of 210. And then king, king, ace, 3/7 times 2/6 times 4/5, or 24 out of 210 again. Seems to come up a lot. And then finally, 3 kings, 3/7 times 2/6 times 1/5, or 6 out of 210. Looks like the most or least likely would be 3 kings, and the most likely would be a king and 2 aces, or king and 2 aces, or a king and 2 aces. 3 different ways to do that. So now we have this tree diagram with all the probabilities listed. It was a lot of work, but now I can use that to answer some questions, like what's the probability of all aces? Well, there's only one way to do that, to get all aces, and that's 24 out of 210. And now I think I might want to try to reduce that fraction. I know I can at least go 12 to 105. And I might even want to just take it as a percent. So 12 divided by 105, so we're somewhere around 11%, approximately 11%. Okay, or what about all kings? So all kings is 6 out of 210. That reduces to 3 out of 105. So we're looking at around 2.5%, 3.105. Yeah, we'll go ahead and round that off to 3%. It's still right around there. So that's all kings and all aces. Now, here's a interesting scenario. The probability that the cards match. So that would take all aces and all kings combined, because the cards match and the cards match. So I have the 6 out of 210 plus 24 out of 210, or 30 out of 210 that the cards match, because these are the scenarios where the cards match, and that reduces to 15 out of 105, which is probably right around 14%. Now, 2 aces and 1 king. So what are all the situations where we get 2 aces and a king? So here's 2 aces and a king. Here's 2 aces and a king. 2 aces and a king. And so we have 1, 2, 3 different ways to get 2 aces and a king, and each one of them is 36 out of 210. So we're going to put all those together. We have 36 out of 210 plus 36 out of 210 plus 36 out of 210. So we have 36 times 3, which is 108 out of 210. That reduces to 54 out of 105. And so our probability on that case, 54 divided by 105, is about 51% of the time you get 2 aces and 1 king. And we could never have done that without working through this non-replacement probability tree diagram, looking at each individual probability, each part as we go.